Hi everyone, I'm Kunal and I'm pursuing PhD in food science at the University of Saskatchewan. My research area include developing food grade nanoemulsions using a protein and biopolymer and making a bilayer emulsions gels and studying their rheological and digestion behavior. The main focus of my research study is to induce the gelation in nanoemulsions by creating the close-packed structures of the nanodroplet at lower oil volume fractions, and this can be achieved by increasing the contribution of interfacial thickness in elevating the effective volume fraction of the nanodroplet beyond the maximum random jamming. With that focus in mind, in this study we prepared the 38% oil in water whey protein isolate stabilized nanoemulsions using a high pressure homogenization. In the next step, to increase the interfacial thickness, the pectin with different magnitude of negative charge was added into the monolayer nanoemulsions at pH 7, and then the pH was changed from pH 7 to pH 3, which led to electrostatic deposition of pectin onto the whey protein stabilized nanodroplet. For better absorption of the pectin at the interface, we remove the excess protein from the continuous phase of the emulsions, and then the rheology and digestion behavior of the nanoemulsion was studied. Major findings of these projects are: droplets found aggregated in emulsion when there was excess protein was there in the continuous phase, and when there was a lower charge, this was actually attributed to the lower charge of overall system because of the excess protein into the continuous phase. On the other sides, the charge density of the pectin also found to affect the droplet charge, irrespective of whether there is excess protein is there or not in the continuous phase. This droplet character is also found to affect the rheology of the systems. For example, the liquid monolayer emulsions was transformed from the viscoelastic self-standing bilayer gels by increasing the interfacial thickness. Two different kinds of gel was obtained in this study: the attractive gel due to the aggregation of the droplets in the presence of excess protein in the continuous phase, and then repulsive gel was obtained when there was no excess protein into the continuous phase, so the pectin was able to adsorb at the interface, and by increasing the interfacial thickness we were able to get the close packed structure in the emulsions. Interestingly, we found that the magnitude of the negative charge with the second layer, that is the pectin, also affected the rheological behavior of the bilayer nanoemulsions. And regarding the digestion behavior, we found that the deposition of the second layer of pectin also found to control the lipid digestibility by controlling the access of the digestive enzyme to the lipid core. Thus, in this research, the gelation in emulsions was achieved at much lower oil volume fraction, that is around 20%, using the bilayer approach, and this can serve as an attractive option to produce the low-fat food products with controlled digestion. Thank you for listening me.